All right, welcome back, everyone. Today we're going to talk about the greatest common factor. In this section, you're going to learn how to find the greatest common factor of a list of numbers and a list of terms, how to factor out the greatest common factor, and then how to factor by grouping. So the greatest common factor of two or more terms is the largest factor that's evenly divisible through all terms. So when we're dealing with numbers, it's the largest number that will divide into all the numbers evenly. If we're dealing with variables, it's the highest power that all the terms share. So if we're looking for the greatest common factor of a set of numbers, right, it's helpful to recall the prime factorization that we talked about at the very beginning of the course. If you can list all the prime factors for all the numbers, then the greatest common factor is simply the numbers that are included in every list. So here at the bottom we have an example. We want to find the greatest common factor of 28 and 40. And we can see we have there the prime factorization of 28 is 2 times 2 times 7. And the prime factorization of 40 is 2 times 2 times 2 times 5. And both of these numbers share in common that pair of 2's. And so the greatest common factor just comes from that pair of 2's, and the greatest common factor is just 4. So let's practice this. I want to find the greatest common factor of each of these lists of numbers. Well, let's start off with 45 and 75. 45 is 5 times 9, which is 5 times 3 times 3. 75 is 25 times 3, 5 times 5 times 3. They both share a 5, and they both share a 3. And so the greatest common factor is 5 times 3, which is 15. We can do a similar thing for 55 and 21. 55 is just 5 times 11. 21 is 7 times 3. Those prime factorizations have no numbers in common. And so if they have no numbers in common, the greatest common factor is just 1. And that's the biggest number that will divide evenly into both of them. And finally, if we have three numbers, 15, which is 3 times 5, 18, which is 3 times 6, or 3 times 2 times 3, and 66, which is 6 times 11, or 2 times 3 times 11. And now we just want to look for what numbers are shared by all of them. Well, they all have a 3. And that's it. That's all they have in common. And so the greatest common factor is 3. So when you're determining the greatest common factor of a list of variables, right, just look for the highest power that's in all of the terms. So here we want to find the greatest common factor of x squared, x cubed, and x to the 5th. Well, just going by the way we solved the numbers just a minute ago, x squared is x times x. X cubed is x times x times x. And x to the 5th is just 5 x's. And notice that they all have those 2 x's in common. And so the greatest common factor is x squared. And x squared is the highest power of the variable that's in all of the terms. So now we just want to find the greatest common factor of each of these lists of terms. We've got x cubed, x to the 7th, and x to the 5th. Well, the greatest common factor is going to be the highest power that's in all of them. And the highest power that's in all of them is x to the 3rd. Here on the bottom we have y to the 1st, and then y to the 4th, and y to the 7th. And again, we're looking for the greatest common factor. And in this case, the greatest common factor is going to be just y. Let's try another example. So now we want to find the list of terms. We're going to combine these ideas of numbers and variables. So again, we can list these things out by just writing their multiplication. 6x squared is going to be 2 times 3 times x. 10x cubed is 2 times 5 times x times x times x. And minus 8x is going to be negative 2 times 2 times 2 times x. And so now we just need to look at what they have in common. Well, they all have a 2 in common, and they all have an x in common. And so the greatest common factor is 2x. We can do a similar thing here on the bottom. We don't necessarily have to write this out because there are no numbers. We just need to look for the highest powers that are in all of the terms. Well, in this case, we have a cubed, a to the fifth, and a to the sixth. So the greatest common factor is going to be a cubed. And then we have b squared, b, and b squared. And so the greatest common factor, or that part, will just be b to the first, or just b. And so the greatest common factor of all these terms is a cubed times b. Now, once you can find the greatest common factor of a list of terms, then you're ready to start learning how to factor expressions. The first step to factoring anything is always to remove the greatest common factor. When we factor something, we don't change anything about the problem. We're just changing the way that it's written, the way that it looks. And as you'll see in later sections, it'll help you solve some problems. And remember that you can always check your factoring by multiplying back. So here we want to factor these expressions by determining the greatest common factor. In our first term, we have 5ab plus 10a. Well, they both have an a, and 5 and 10 are both divisible by 5. So in this case, the greatest common factor is 5 times a. If you weren't sure about that, list the terms out and work it the same way we did the previous examples. Now that we have the greatest common factor, we want to factor it out of this expression. So what that means is essentially divide. We're going to write 5a in front. And then 5ab divided by 5a, well, the 5's and the a's cancel, and what you're left with is just b. And 10a divided by 5a, well, the a's cancel, and you're left with just 2. And so we can factor out the greatest common factor, 5a, and what we're left with is b plus 2. And you can check this by multiplying. 5a times b is 5ab. 5a times 2 is plus 10a. And we get back what we started with. We can do something similar for part b. Here we have y to the fifth and y to the 12th. The greatest common factor is going to be y to the fifth. And so we can factor that out of both terms. And so we'll write y to the fifth in front, the greatest common factor that we're taking out. And y to the fifth divided by y to the fifth is just 1. And y to the 12th divided by y to the fifth minus y to the 7th. One of the biggest mistakes that can be made is when you remove something that's the greatest common factor, like y to the fifth in this problem, and forget to put the 1 in its place, right? So y to the fifth divided by y to the fifth is equal to 1. It doesn't go away. And so you have to include that 1 within the factored component. So in this case, the greatest common factor is going to be 3a. And so we're going to divide each term by 3a. We're going to write 3a down in front. Negative 9a to the 5th divided by 3a will give you negative 3a to the 4th. 18a squared divided by 3a is going to give you 6a. And then 3a divided by 3a is just 1. So use the method from the previous examples to determine the greatest common factor, and then remove the greatest common factor by dividing. So one special case of a way to factor is known as factoring by grouping. And in some cases, this factoring can be accomplished by just using the greatest common factor. To factor by grouping, we're going to group the first two terms and the last two terms, and then we're going to remove the greatest common factor, and then use what's remaining to complete the factorization. So let's practice this. Here we have xy plus 2x plus 3y plus 6. So let's just rewrite that problem. And we're going to group together the first two terms and the last two terms. And from each of those, we're going to determine the greatest common factor. So for the first two terms, the greatest common factor is x. And we're left with x times y plus 2. For the second two terms, the greatest common factor is 3. And we're left with 3 times y plus 2. Notice that in both groups, we're left with a y plus 2. And so now, if you look at this thing holistically, right, y plus 2 is the greatest common factor, because each of those terms has y plus 2. So we can factor out the y plus 2, and then just write what's left. And you get y plus 2 times x plus 3. We could do the same thing here on the bottom. (15x cubed minus 10x squared plus 6x minus 4). We're going to group the first two terms and the last two terms. And here in the first two terms, the greatest common factor is going to be 5x squared. And when we take out 5x squared, we're left with 3x minus 2. And in the second two terms, we can take out a 2, and we're left with 3x minus 2. And now each one has a 3x minus 2. And then we just write down what's left, 5x squared plus 2. And so at the end of this lesson, you should be able to determine the greatest common factor of a list of numbers or a list of terms. You should be able to factor out the greatest common factor from given expressions. And you should be able to factor by grouping.